Okay. Okay. Yes, I can. All right, let's take a picture of that. And then you're gonna. How many of these do you have before your next Nollies check? Okay. Cool. All right. What does it say? If you scroll down there. Which is this regular log. All right. Let's take a picture of that. So it looks like they're using the log rules again. Alright, you go down a little bit. Type out the X. Let's take that picture right there. So you have to type in that big old long mess, huh? Okay. What I want to do today when I'm doing the work on paper to show you, I'm going to switch over to my view so it's full screen so it'll be nice and big, if that helps a little bit. Okay, I'll take a picture of that. Alright. Should be pretty straightforward using those log rules we've been using. Negative 3x equals 5 to the x plus 6. Alright, can you stop sharing your screen for a second? Let's see if I can make mine better. You can? Well, I want to get the recording because my recording is recording your computer screen right here. I'd rather the recording record real big the work I'm doing there. So let me try to get that going. Whoops. Right.
What's the date today?
16th. Let's see here. So what are you seeing there? All right, I'm trying to. Don't want that. Shoot. Huh, it's weird.
God, you're like shaking.
You see the writing right there? Okay, well, let's do it right there. Alright, sorry about all that. But I want you to be able to see and then make that big, make it a little bigger. Alright, so the first thing I'm going to do is write that in log form. So I'm going to write it like this. I'm going to write it log. You can see that? And that 6 right there, that's going to be the number I put in front of log. That's kind of going to be its log number. And then I have up there negative 3x. And on the other side, I'm going to do the same thing with that 5 and that x plus 6. If you can see that. So you're changing them to log form. And then I'm going to take these exponents and I'm going to bring them both down to the front. So my next step will be negative 3x log 6 equals, in parentheses, x plus 6 log 5. Alright, and then the next step, they left that negative 8x alone. They distributed this through. Alright, so now my next step here is to distribute this part through. Get my pencil going here. So that leaves this as negative 3x log 6 equals x log 5 plus, oops, not log 5, yeah, no, that's right, log 5 plus 6 log 5. So I broke that up into two little parts right there. And then, let's see, gathering of x terms. Let's see, what did they do? So they added 8x log 4. Alright, now what they want you to do on this is I'm going to get rid of this term over here and leave this one alone right there, it looks like. So that's going to give me, if I take away that x, it's going to be minus x log 5 minus 3x log 6 equals, if these go away, 6 log 5. See how brutal that is? And then my next step is to take out an x out of this whole mess right here. Let's go back to my pictures there. So if I take out an x out of this and put an x out front, what would have to be in there to get that back would have to be negative log 5 minus 3 log 6 equals that 6 log 5. So what I did is I factored out a positive x out of this. Kind of brutal, huh? I could see why these were just sucky. So my next step is to divide both sides by this negative log 5 minus 3 log 6.
What is it again? Oatmeal?
And that looks really messy, but all this junk clears. And your answer is x equals 6 log 5 over minus 1 log 5, or just minus log 5 minus 3 log 6. I believe, looking at that, that's how it's going to be set up. I mean, I might have made a tiny little mistake. That looks real similar to that picture that you sent me. So if you want to go back to your screen there, so you got 6 log 5. Minus some negative there. There you go. Log 5 minus 3 log 6. Cross your fingers. I mean, if we're off by a tiny little bit. Yay! And then it's good. You got all that on video. It looks super complex, but it's just kind of breaking it down by log rules, and it does have that weird factoring out an x part. So I'll show you another one there. But we got that one right? Yeah. All right, so 5x minus 7
That's not much enough to show.
equals 9, 6x. All right, you want to go back to that split screen? All right, you see that? Awesome. So I'm going to apply the log rule to that. I'm going to log this and log the 9. So it's going to be log 5. Feel free to write as I'm doing this. Equals log 9 to the 6x power. And then I'm going to bring these little exponents. Remember how I brought those to the front? I'm distributing after I bring these exponent chunks to the front, then this one I'm going to distribute. This one I'm just going to leave alone because there's nothing to distribute. Kinda, I guess. So this next step is taking this x minus 7 piece and writing it in front of the log 5. And then on the other side, taking that 6x and writing it in front of the log 9. What do you think about that? And then now, this is where I'm going to distribute. I'm going to write this as x log 5, and then I'm going to write this as negative 7 log 5. See that little distribute right there? So that gives me x log 5 minus 7 log 5, and I still have that 6x log 9 over there. Nope, now I'm gonna get this term right here. I'm gonna add this to what I'll probably do is we want to get the x's on one side and this plain old term on the other. So I'm probably going to leave this one alone and subtract this one right here. So that will, when I minus x log 5 over here, these will cancel away. And that leaves me negative 7 log 5, and then over here I have that negative x log 5 plus 6x log 9. And then over here I'm going to take out an x, and then I'm going to divide both pieces. So I leave this, what's that? No, I'm not touching that yet. I'm going to factor out an x out of this mess. So if I put a positive x out here, you got to know what, if this was an x here, what times that x would give me this, and then what times this x would give me this term right here. So the only thing times x that would give me negative x log 5 would be minus log 5. Because if I distribute that times x, that gives me this. And then to get 6x log 9 from x, I'm going to write that as plus 6 log 9. Because if I take that x times that, that gives me 6x log 9. That's kind of confusing step right there. And then to get this x by itself, now I'm going to divide both sides by this whole yucky mess right here. So I'm going to divide this whole side by negative log 5 plus 6 log 9. And I got to do the same to this side of the equation to keep it balanced. All that crap will go away. And then it's up to you to type that in as accurate as you can with that -7 log 5 over negative log 5 plus 6 log 9. And it looks harder. These look harder than they really are. It's just a lot writing logs and stuff. You gotta let that go. It's kind of weird. Hopefully that works. Negative log 5 plus. Yep. Did that one, was that right? Yeah. Happy. 8x equals 7 to the negative x minus 3. So done the exact same way. Are you ready? So I'm going to log it out. Let's see if I can make this bigger. Let me try one thing here. Alright, so I'm going to write this as log 5 8x equals log 7 negative x minus 3. Remember doing that? And then I'm going to put those out front, put those pieces out front. So that will be 8x. And then I still have that log 5 equals, in parentheses, negative x minus 3 log 7. What do you think? You okay right there? And then that's going to be where you're going to distribute right there. And then you're going to factor out an x. And then you got to rearrange all the x terms on one side and the others on the other. So this will be 8x log 5. Over here I get negative x log 7 minus 3 log 7. What do you think about that? Yep, and that x, see how that goes to the front? Can you see? Is that kind of washed out? Okay. I'll try right bigger. And then at this point, I need to get this x term over here to the right side. So this is minus here. I'm going to add. Which will go away. And that leaves me x log 7 plus 8x log 5. And then over there, can't forget, that's not this regular 3, that's minus 3 log 7. Alright, what do you think you do from there? But before you divide, you need to factor out an x out of here. Remember how I put an x out front like that? So take a shot at that. What do you think? Because there's only one thing that could be inside here times x to give me this, and only one thing to distribute and give me this over here. Yep, just plain old log 7. Now the trickier one. No, it wouldn't be negative. Got an x already here. So what, with this x, what times this x would give me this 8x log 5? That's the key. So 8. What else? There you go. So this is the piece right here that you're going to divide this by. Yep. So your final answer is that negative 3 log 7 that was left on that side over there, divided by this piece that you had in that parenthesis right there, 8 log 5. So it's gonna, it's just, it looks more complicated than it is. Dogs are wrestling. Said my dogs are wrestling, so if you hear them. That was it was negative 3 log 7 over log 7 plus 8 log 5. There you go. All right, yeah. Yeah, I could see why those were a struggle because, I mean, there's so many little things on that. But so it looks like you got some other sections done on your own, though, so good job. Okay. All right. Okay. Good. Good on ya. Okay, so here we go. These. Yeah, hold on, let me take a picture of that. That's okay. Alright. Good. Alright, you can scroll down. Take a picture of that. So these are pretty much plug-in numbers. Not too bad. Okay. What's it say next? All right, and then go down a little bit. All right. Oh, these are brutal. And then go down a little bit. Now you got to plug in T right there. It's 14. All right, go down to the answer. All right, Sadie, good luck. We got these. No problem. Okay, so let's go to this right here. So I'm just going to write down 20 fish and 19 years. Is that what they're asking? There are 52 fish after 9 years. All right, so the initial is 20 fish. Okay, do you want to go to my screen there? One more here, let me take a look. All right. So looking at that here, you got the formula. You're gonna have. Let's see. Let's go to this. So this formula y equals y0 e to the r t. See that? So I'm gonna. This is the initial number right here. So the 20 goes right here. The final is this one right here, I believe, 52. So I'm going to put those numbers into the formula here. Let's take a look at this. So I have y0 is going to be 52, I think, because that's not the initial. The initial is 20. So that number goes right here. I have E, and then R, T, I got 19 for T, so this is going to be written as 19R. Do you see that? So next step, I'm going to divide by 20. And that gives me, let's see, 52 divided by 20, that gives me 2.6 equals e to the 19 r power. See that? And then next I'm going to start to use the log rules. So I'm going to use natural log because of that e. I'm going to use that ln 2.6 equals ln 19r. And then by definition, I could write that as ln 2.6. Whoops, this is an e right here. Anytime you take the natural log of e, these just pretty much cancel away and just leaves you the 19r right there. So to solve for r, I'm going to divide by 19, and that gives me r equals natural log 2.6 divided by 19. And then what does he have to do? So I guess I take that r and I go back to the original equation and I write this as y equals 20 e, and then in parentheses ln 2.6 over 19 times t. So that is going to be your first answer you're going to type in. The second one, I'm going to plug in t is 19 right there and do the math. So let's see that part. So my second part B, comes from 20e to the ln 2.6 divided by 19 times 19, I believe. I think, ooh, God. Yeah, hold on one second. Let me take a look at that problem one more time. Alright, almost there. Alright, go back to your problem. Because it might not be 19 that you're plugging in. Oh no, it's 21. Alright, so your first answer there, if you're ready, type that in. 20. And then inside there, that's ln 2.6. You gotta do the fraction thing. Natural log 2.6, and then on the bottom you got 19. That's that one. And then let's use you have your calculator there. Let's open that up. So that's 20 e to the x, and then good luck writing that in there. You can do it. Look at that. Good job. Getting good. 2.6 over 19. Close that power. And that time's got to be up high in that exponent zone. Times 21 right there. Yeah, because we're using 21. Yes, for that second part. And then round to the whole near number, so 58. Alright, if we missed it, something minor that we did. Yay! Alright, got another one of these. So 280 is the initial. The final is 588 after 7 days. And then the final one wants me to plug in 19 days. Alright, I'm ready if you want to follow along with what I'm doing here. Hopefully this is working out for you. You can see good enough. And okay, so again, I'm going back to this. Y equals the initial e to the RT. So the initial amount is 280, goes right here. 588 is the final amount, goes right here. So 588 equals 280 E, and then 7 is my days, would be, make this to the 7R power. Divide by 280. And then on my calculator, 588 divided by 280 gives me 2.1. Now I'm going to use the natural log rule. Natural log 2.1 equals natural log e to the 7r. By definition, these will cancel out and leave you 7r. So we have ln 2.1 equals 7r. Yes, ma'am. Just by 7. And you're left with r equals natural log 2.1 over 7. That I'm going to take and plug all the way back into here. So my final answer for part A is y equals that initial amount 280 e, and then natural log 2.1 over 7t. That's the answer to A. And then your final answer, when you plug in 19, you're going to use your calculator to do all that. Yeah, pretty sure it's 19. Yep, it's all exponential growing rate. Good stuff. How those other classes going? Yeah, sure. Yeah. I bet. There you go. Good job. No. Yeah, I know. My son who's going to Chico, he'll be bummed if the first semester is all online. He doesn't know what he's going to do. I mean, I don't know. I think that should be good on this. 2.1.
You know what you should do?
Ha!
Do you have
There we go.
answers for all of like the stuff we do, or just the quizzes?
I have answers for everything.
You should give me the answers for English. I don't have to do anymore since she's changing it anyway.
You have to get through that. You have to complete it.
Yeah, I know. So you should give me the
Uh-huh.
answers so I can
I thought you only had one more activity.
No, I still have to do analyzing.
Where is
That
that?
was the next thing.
At Chico?
Yeah, but I'm behind. So
Oh, okay. Cool.
I have to do this. I have to listen to a 20-minute.
No, I can't pass you past that.
No, I know, but you
Oh.
give me the answers, so you don't have to listen to it. And
But
this-
you have to listen to it. You have to go through the whole thing.
I know,
Okay.
but I'm saying I can
That's
listen
cool.
to it and then
Yeah.
do something else,
Oh,
Yeah, well, it's
so I don't have to pay attention.
all right. Got another one of these. So initial y to the 0
okay.
is 6,200.
You have to. You can't get
Uh,
to the quiz until
the
you've gone through
final
the quiz
y
ahead.
No, I'm saying
is 2914,
Oh, it gives you.
and time
you have
is
to answer
22
I have to do a bunch of
minutes.
stuff, not just quizzes.
everything.
All right, got it.
Okay.
And then I didn't see what that final part B was, but we'll get that. 23 minutes. Okay. Okay, so going back to this, I'm just going to keep writing this. The more I write it, the better. That one. So 6200 is the initial, and then y is the final, goes here, and then
Where are you, Jay?
22 goes here. So that would be
Analyze rhetorical strategies.
2914 6200 e to the 22 times r power. And this is where you start doing that natural log
Analyzing
stuff.
rhetorical strategies in presidential speeches.
I thought you were at a Zoom meeting, Nathan.
Oops.
I do, but it's what?
Oops. I should have divided
What's the matter?
first. That's my mistake.
I was just upstairs and then
So I'm going to
Okay, so can we
divide
jump back in.
by 6200 first before I start doing natural log there. Whoops. 2914 0.47. Alright, now I'm going to natural log that. And then again, remember, natural log in E cancels and just leaves me this. Divide by 22, and that's my R value.
I don't know if these are.
So again, I'm going to take that and plug that back in here
What's your first question?
to get the first answer. So my first answer is y equals 6200 e to the ln 0.47 over 22t. Then your final answer will be to plug that 23 in for that t. There you go. All right. That should be the last one for those.
What?
Nothing for you. Silly dog. Can't find my blue glasses.
Good job. Yep. There you go. Good job. All right. All right, they look pretty similar. Yes, please. Yeah, better to get all this.
Were you able to get back on, Nathan?
Can you go up a little bit for that blue box? So So now you could go down right there. Perfect. All right. It's pretty much the same problems there. This is going to be decay, so might use a negative for R. So go down. Nope, doesn't look like it. Ooh, look at this. Take a picture of this. Half-life. So y is 0, 38.7, t is 4, y is 0.5. The initial, you got to take 0.5 times 38. Wow. It's still pretty much the same, but you can't just plug in the final number in there. You had to times it by 0.5 first before you plug it in. So half of 38.7, that's where you get the final number there. I think, yes. And then divide, and then use a natural log. Alright, you go down. And then looks like they're the same pretty much, except that they don't give you a final value. You have to find it yourself. Alright, got it, no problem. So initial y is 0, 9, 3, 2.3, half-life 16 minutes. That means y equals 0.5 times 932.3. Alright, I got it. See that? Okay, so this right here, to get the final, I had to take the half-life of the initial amount. That's what I'm doing right here. So when I go back to this original equation we've been using for the last section or two, the y number is 0.5 times 932.3. And that is 466.15. The initial amount is the 932.3 e to the 16r, because that's 16 minutes. Hopefully you can see that. I'm going to divide by 932.
So you're not there yet? I need my Chromebook back. I need to use.
Well, what is this?
Well, that's what I'm asking you. Get to your
And that
first
gives me
question so I can find
0.5.
I did, and it wasn't one of these. I think this is when I have to do like an activity.
it. Well, all there
And then,
is
sorry, it's
is
getting
that-
washed out a little bit. It's just the window is bright. And then I'm going to natural log it. Natural log
questions,
0.5
practice questions. I don't know what these are.
equals natural log e to the 16 times r.
No.
Cancels.
Where are you?
Natural log
Right here.
0.5
Watching a video.
equals
Without the
16
instructions.
r. Divide by 16. So now if I plug that in, the final answer y equals 932.3 to the ln 0.5 divided by 16 to the t power. That's the first one right there. And then my next one, I'm going to plug in 22 right there for my answer. So the initial amount times ln 0.5 over 16 times 22. That should be second answer right there. Yes.
I'm gonna make a shield.
Yeah.
Shield of what?
Done.
I think that'll make it way easier. I was fixing up my dock cam there, so it'll be less washed out there. Yep. Nearest tenth. Uh, 0.5. There you go. Yay. Customary not to start a number with a decimal point. Alright, whatever. Okay, so here we go. Looks like the initial 6.3. 12 minutes. That's millimeters squared. Yep. I mean, I don't even really care about the unit. All I know is the initial is that number, and I'm going to plug it in. I know that the time I'm going to use for that first equation is 12. And then that final one, I'm going to use 7. I'm using... this is doubling, so it's not decaying. So I'm taking my y value is going to be 6.3 times 2, I believe. All right. If you're ready to switch over, I can show you. You see that? So if I take 6.3 times 2, that gives me 12.6. So that's my final value. So I'm going to write, going back to this equation we've been using, 12.6 goes here. 6.3, the initial goes for a y to the 0. I'm using 12 minutes, so I put that right here for t, and that gives me 12r. And then you know what I do next, right? Yep. Yep. Keep going. Yep. Same exact thing. Keep going. And then natural log it. And then you know what happens right there? So these are going to cancel and leave you ln2 equal. Now you're going to divide it. There you go. So all that work just gives me what R is to go way back and just plug it back in. So my first answer is y equals that 6.3 e to the ln2 over 12 times 2.
No.
All the way through clauses?
No.
The second part will be
When I do
6.3 e to the
Yeah, because I checked on her new
ln2
thing. She's already got people at like 7% on the new one.
times
Wait, she
7.
has a new one?
Yeah, you remember when you're done with it, she moves you over to the new one. Some people have already started that. So look. So the sooner you can get done with that, like today,
I don't
let
think
her
so.
know, she can move you over to the new one.
I'm hoping
Yeah,
not.
I get it done today.
Yeah.
Nearest 10th, yes. Got those down, easy peasy. Okay, so this is doubling. The 9.9 at the beginning is the initial. Doubling time 22 minutes, and then the last one is 15 minutes. All right, no problem. Okay, so first step is to find what y is. So y equals twice 9.9, because I'm not half-lifing, I'm doubling it. So the final amount is 19.8. So now I take those and plug them back into this again. The final value 19.8, the initial value 9.9, e to the 22, because it was 22 minutes it gave you, e to the 22r. So jumping ahead, this answer is going to be r equals 19.9. You know what? Let's not skip. I'm not going to skip anything there. All right, so divide by 9.9. 19.8 divided by 9.9 is 2. Natural log it. Don't forget to put that 2 right there. These cancel away, and I'm left with ln2 equals 22r. Divide by 22, and that gives me what r is. Yep. So part 1 is y equals the initial amount 9.9 e to the ln 2 over 22 times t, and then the next one where you plug in 15 into that. We're getting this distance learning thing down. It just takes a little bit. And then you have record of this too. You'll be able to go back and see, and then showing step by step. Yeah, but now it will be way bigger because that half screen that you're seeing, that I see, you'll be able to clearly see that. So that would be better, I think. It was 15, yeah, for that last one. Hopefully. A lot of log stuff, and yeah, a lot of mistakes. Sure. Alright, so these are a little bit better. I'm glad they're different. If you want to go back up to that top one. Right there. Alright. So log 5 x minus 8. Log 5 x minus 8. Adding plus log 5 x minus 4. Same base. Okay, you go down a little bit there. Let's take a picture of that. So the same base. They foiled the inside part. Ooh, look at that. And then they use log 5 rule. Alright, go down. And then you gotta plug it in and check them. Alright, go down to the bottom. So So only one answer is good. All right, that makes sense. Wow, these are intense. I've never seen math done like this before. But it's all totally doable. All right, you ready? Okay, negative log base 2x plus 4 equals 2 minus log base 2x plus 7. All right, I got that on paper. If you want to switch over, I could show you what I do on this one. Okay, so the first thing, I'm going to isolate this 2. I'm going to add log 2x plus 7. Those will cancel away. And that gives me log base 2x plus 7 minus log base 2x plus 4 equals 2. Do you see that? And this is subtraction, so I'm not going to times these two. This is division. So by definition, I could write this as log 2x plus 7 divided by x plus 4, just like that. I think. And then looking at how that other one was done, I think there's a rule that lets me just write this x plus 7 over x plus 4, and I use this number over here as the base, and I use this number as the power. So that gives me x plus 7 over x plus 4 equals 4. And then I believe on this one, I'm going to crisscross multiply it and solve. I'll have x plus 7 equals 4x plus 16. Take away 4x. Oh, this one's a tenth. Take away 7. Divide by negative 3. Gives me negative 3 is my answer to that one. I think. Yes. I'm pretty sure. I mean, because I know up here when I split it up, this is not timesing these two, so I'm not going to FOIL them. I'm going to divide them. Where if this would have been a plus right here, I would have FOILed these two right here. And then I'm pretty sure about this. The math, 4x 16, the math looks pretty good. So I'm pretty confident about that if you want to try to type that in. It was? All right. That was very intense. Okay, got it. Okay, we got log 5x plus 2 equals 1 minus log base 5 x plus 6. All right, I'm ready. So I'm gonna isolate this one. I'm gonna add log base 5 to both sides. These are going to cancel away, and I'm left with log base 5 x plus 6 plus log base 5 x plus 2 equals 1. These are adding, so I'm going to FOIL these two. I'm going to write it like this: log base 5, and inside there I got to take x plus 6 piece and not divide it, but times it by x plus 2. Times it.
Multiply.
Well,
So I got to FOIL all
That's it,
this.
times it. You should be saying that.
okay, so.
So when I FOIL that inside there, I get log base 5
Like, do logs writing.
x squared plus 8x plus 12.
Yeah, that's what the.
So that comes from x squared, 2x, 6x, that's where I get the 8x. And then 6 times 2, that's where I get the 12.
How did it let you do
And now my trick is
No, I'm saying
I write this as x squared plus 8x plus 12
But like now I don't have to pay
equal
attention
to this number as the base with this number as the power, which gives me this. I'm going to take away that 5 right there, and that gives me x squared plus 8x plus 7 equals 0. I got to solve this by factoring. So the only two numbers that work are 7 and 1. So that gives me x plus 7, x minus 1. So my two answers are -7. I'm sorry, those are both plus and -1. Sorry about that. That was positive too. So now I need to. No, they're both negative. Both these are positive up here, which means my answers are both negative. Now if I look back at my original problem up here, hopefully that comes into focus. This is the original problem. My two answers, -7 and -1. The problem is, if I plug in -7 right here, that gives me -5. You can't log a negative number. If I plug in -7 here, it gives me a -1. Can't do that. So that answer is off the table. If I take this -1 answer though, if I plug in -1 right here, that gives me +1, which is okay.
I just had to shut down that.
And if I plug in -1 here, it gives me 5, which is okay. So that means that of those two answers, only -1 is going to work. This -7 one is going to give you a bad answer. So I'm pretty sure -1 on that one. That was a pretty intense problem. Yep, all that work. Yeah, those are very intense. What we got. What happened? Oh, what happened? Previously learned. That one, exponential log functions. All right, let's knock this out. You ready? Let's take a picture. Alright, so it looks like they're breaking it up into a log problem again. They are bringing the log numbers out front, not too bad. Alright, you go down. Looks like they're distributing that negative x through and that negative 10 through. God, didn't we just do these?
So do you know what to do now, Nathan?
Yeah.
Okay.
God, I thought we just
You
did
have a lot
these.
to do.
Alright, we should be able to do these no problem. They're just
Kinda.
really yucky
Put in
and messy.
big chunk of hours today.
Yeah.
Alright, 17x minus
You gotta
9.
get caught up on what?
Caught up on Edgenuity. I'm
Yes.
just like an hour or two behind in econ and English.
Yep.
Alright,
So
you
gotta
can switch.
Put in extra time so that you don't fall behind. You can't just do that. You gotta do extra.
Alright, so I'm going to write this as log
They say you'll be working till dinner time
17x
today.
minus 9 equals log
You can practice for college.
16 negative 4x. And then I'm going to bring these to the front and write this as x minus 9 log 17 equals negative 4x log 16. This is going to distribute through. So I'm left with x log 17 minus 9 log 17 equals negative 4x log 16. I'm going to take this term over here by subtracting. And that leaves me negative 9 log 17 equals negative x log 17 minus 4x log 16. I'm going to leave the negative log 17 alone. And on that right side, I'm going to factor out a positive x, which on the inside here will give me negative log 17 minus 4 log 16. Divide by negative log 17 minus 4 log 16 on both sides. And I think after all that smoke clears, x equals negative 9 log 17 divided by negative log 17 minus 4 log 16. Oh my goodness. Yep, all that mess. I'm going to switch over so I can see. Take a look at that. Santa Cruz County opened up their beaches and parks and open spaces.
Oh, wow.
Hope our beaches get open soon so I can start surfing again.
Yeah. Right.
No, I haven't. He's on drugs. That sucks. Ooh, careful. I think you need to redo that one. I'm sorry. think you got a parenthesis in the wrong spot. Sorry about that. Yeah, on that bottom one. So that top part is 17 up there. And then that bottom part, negative log 17 separate. You close that parenthesis. Minus 4. There you go. Yeah, you had parentheses around that 17 right there. That would have. You would have been sunk. 16. There you go. That's better. Minus 4 log 16. There you go. That's different, yes. Round to the nearest thousandths. Yes. Alright, so keep going. What happened? That looks good. Mm-hmm. Yeah. Right. Right. Wow. Wow, that's sketchy. I'm glad that he didn't attack you or something. Yeah.
Where is she?
She ran into a homeless guy down the pier, she was saying.
Oh, she's not there right now.
No.
Oh.
My wife was concerned. She's like, oh, that's sketchy. Wow. All right. Yeah, no doubt. Okay, this one I'm ready. Yep. Okay, so I'm going to log it out already. And then bring those pieces to the front. So it's negative x minus 10 log 14 equals 10x log 3. So all these problems are done the exact same way. You take those, log them out, write those exponents out front. I'm going to distribute this like I've been doing. And then the tricky part is rearranging it and taking the x out of it. That's what gets weird. But this part right here isn't too bad, writing it like this. Now when you distribute it, now it gets a little weird because you have negative x log 14 minus 10 log 14. And on the right side, you still have 10x log 3. Now I want to bring this term over to the right. So I'm going to add it. And that looks tricky algebraically, but that leaves you negative 10 log 14 equals x log 14 plus 10x log 3. And then I factor out an x over there. So that'll give me x log 14 plus 10 log 3. And then my final step is divide that whole mess. Gives me x equals negative 10 log 14 over log 14 plus 10 log 3. Wow. Look at that. This looks like a mess. Negative 10 log 14 plus 10 log 3. Negative 10 log 14 plus log 3. Hope that's right. Ten log 3. There you go. One more, yeah. They're really long and they're really messy, but I mean, again, math compared to the other ones. So 13 5x equals 16x minus 3. All right, you ready? I'll show you. Can you switch the views over so I get that on film for you? So 13 5 the x, 16x minus 3 becomes log 13 to the 5x power log 16x minus 3. I'm bringing these powers down like we've been doing in front of the log. I'm going to distribute over here. 5x log 13 equals x log 16 minus 3 log 16. I'm going to take away x log 16. Gives me 5x log 13 minus x log 16 equals negative 3 log 16. Wow. Take away an x out of here. Gives me 5 log 13 minus log 16. I'm going to divide this whole side by 5 log 13 minus log 16. So after all that, x all by itself is negative 3 log 16 over 5 log 13 minus log 16. Just like that. Oh, wow. Messy. Gnarly. Hopefully it's right. I don't want to go backwards on those. -3 log. Oh, what'd you get? -8 Nope. Yay. What's next? What do we got? Alright, go back. Alright. Ooh, whatever that means. What does that mean? So all the other parts of the pie you were good on? Yeah. Looks like that one on the right you gotta do. You sure? Okay. Okay. When is your next test again? What day do you think you're gonna do it? So Monday, Tuesday of next week. That will be your second test. All right. Okay. Sounds good. Yeah. Sounds good. Okay. All right. Okay. Well, look for this video. I'll send the link to you. And hopefully you'll be able to see like this, nice and big. All right. Good luck, Sabre. Bye.